right, thank you everybody coming out. I know we got a long weekend, but to get it started, we'll have some ISSessions. So as usual, we'll be starting off with the news roundup. Afterwards, we'll be going into our break. And after that, hopefully we'll be joined by Taz and Sylvain for some detection engineering talk and how to get into that career. Pretty interesting field. Hope you guys enjoy it. So to get started off with the news roundup, Nintendo's been getting a lot more ambitious with their properties here. On September 12th, IFX Networks, which is a telecom company, a pretty big one in Latin America, they suffered a cybersecurity incident recently, which ended up disrupting the operations for 762 organizations across Latin America, especially Colombia. So the group behind it, Ransom House, they're a relatively new threat group, showing up in the last 2 years or so. Originally, they started off just stealing company data and then extorting them that way, trying to get them to pay the ransom. But as of recently, they've moved into actually encrypting company files. One of the tools they use for this is the Mario ransomware. Fun fact, it got the name when Ransom House was attacking some municipalities in Italy, so I guess they were trying to rub it in a bit more. There's also a lot of reports going around saying Mario Locker was the tool used against IFX. This does not seem to be the case. Mario Locker seems to be a completely separate Super Mario themed ransomware. That one targets Windows machines. This one targets ESXi servers. ESXi, it's a hypervisor from VMware, so it's used to run virtual machines. So a very juicy target. A lot of ransomwares are going after those servers, especially in Colombia apparently, because Ransom House was also behind the attack against Coralty in 2022. Coralty is a very big healthcare provider in Colombia. That was a pretty bad one. Apparently patients were waiting like 12 hours to get care. But Mario's reign of terror seems to have ended here, as all clients are reported to be back online as of September 24th, according to IFX. And it doesn't seem like any data has actually been published on Ransom House's leak site, so they seem to have gotten away scot-free. But maybe not quite, because it looks like there's going to be some lawsuits headed IFX's direction. The Minister for Information Technology from Colombia, he says they're preparing a civil case, potentially even a criminal case. And the Colombian president even had some less than favorable words about IFX's security measures. So we'll see how that plays out.
So for the next news item, Cisco warns of critical flaw in emergency responder code. The code just reroutes 911 calls to the police. So they issued an advisory for vulnerability that would allow unauthenticated remote access to the device, and pretty much the developer just left the root user credentials hard-coded into the code. It was a CVSS score of 9.8, just because they can log in with the maximum privileges and do an RCE. And it was discovered during internal security testing, and the issue has been solved for current versions. So this goes to show how bad hard-coded credentials are. And for the next item, it is a APT group attack on government and telecom orgs in the Middle East. Budworm is a long-running APT that is believed to have been active since 2013. They often target high-value victims, government, technology, defense sectors. Symantec discovered Budworm using an updated version of its sysupdate backdoor to target Middle Eastern telecommunications organization and an Asian government. Budworm uses a legitimate application to sideload the DLL on victim networks. SysUpdate is a backdoor with capabilities such as list, start, stop, and delete services, takes screenshots of the user's computer, drive information retrieval, file management, and command execution. In addition to SysUpdate, the group also used adfind, curl, secrets dump, and passwords dumper. In March of 2023, Trend Micro reported that Budworm developed a Linux version of SysUpdate with similar capabilities to the Windows version. And you guys can visit the link there. to learn more.
All right, and to wrap up our news story here, so recently the FBI put out a warning. This is regarding the rising trend of dual ransomware attacks. This is when companies get hit in quick succession. So maybe the ransomware actor deploys Mario ransomware on their ESXi servers, and then they use Mario Blocker on their Windows machines. So they're saying that there's a big warning here, especially in the United States. They're also seeing threat actors are using different techniques. So they're using encryption as well as data exfiltration. This is partly because backups have been getting a lot better as of lately, and companies have also been getting better at backing up their stuff. But if you steal the data, what you gonna do? So in most cases, this second attack usually comes 48 hours after the first, but there's also reports of attacks happening up to 10 days after. In order to mitigate, they've provided pretty general security posture recommendations. Maintain your backups, always patch your software, system leaks privilege, the stuff you're learning in first year. And specific companies, of course, have not been named that are being affected here due to security reasons. So with the news, we're going to get into our break. We got the CCR code up. Abdul, you got the? Yeah. Perfect. So after that, we'll be joined by Taz and Sylvain for their talk on detection engineering. So hope to see you guys there. All right, we're ready to kick it back off. We got a couple presenters here, Taz and Sylvain. They've done some presentations for us in the past. They've been good in my opinion, so I look forward to this one and hope you guys do as well. Take it away.
Hi everyone, welcome, and thank you first of all for the team that letting us present in here. Yeah, let's start this really serious presentation about detection engineering. So just a quick, probably why we want to do this, because if we ask you like what do you want to be after you're done school, it's gonna be like pen test, but you know what, let's introduce something cool from the blue team sides that you can be working on.
Maybe let's ask, like, show of raise of hands, like, who wants to be more on, like, the red team side?
Offensive security.
Okay. Three? Okay, interesting.
Interesting.
Like, back in the day, it's like...
I don't think we should continue the presentation. No, okay. Yeah, so that's the idea. So yeah, we can start. This is actually a serious presentation, so that page before it's not the real intro. So yeah, so I'm Taz, this is Sylvain. We are alumni from the college too. And yeah, I myself work for Microsoft. I'm working in their security research, mainly in the cloud. I'm also part of the DFI report. If you go on Twitter or X these days, you'll see a free report, full-blown investigation from the start to the end, and also a member of Curated Intelligence. You can find me on X, you can find me on Discord, and also on LinkedIn.
Yeah, I'm Sylvain. I'm a senior security developer at Arctic Wolf. I'm on the Precogs endpoint team, which is like our internal team name for like the detection engineering team. So yeah, and man, what year did we graduate? Like 2018?
18.
So, yeah. Me and Taz, we've known each other for like
Since then.
since
Ever
then.
since.
Yeah, and it's crazy because we were in the same starting cohort. I think we were a class of like 80 at the start.
Yeah, 2014, 80 people.
Yeah, and then only 10 of us, like from the original group, made it. So
Yeah.
like we know the struggle that you guys go through, and it's pretty insane.
And those people are like good people. So if you see these people, you probably see them in the next 20 years, 30 years, something like that. So yeah.
Okay.
Disclaimers. Okay. I'll speak on the behalf of both of us. So this talk is our own stuff. It's not what our company tells us to do. So we just leave it here. This is a guide, not like ultimate guide. So you use it. Use your caution to it. So just a real quick. I think it's yours. Yeah.
Yeah, this is a quick glossary. Like honestly, we just have this up here so that way, like when you go look at the slides again, like we're gonna distribute it to you guys because there's gonna be links and stuff that you'll want to have access to. It's just like quick reference for what they mean, but
Yeah,
we'll go over these.
especially for like new first year, second year, it's probably like a lot of acronyms that we don't know. You can
Yeah.
find it here.
Okay, yeah, just an introduction to detection engineering. Like, let's first of all, like, what is that? What does that even mean, right? And we'll just like understand kind of like the fundamentals of it. So, well, firstly, let's talk about like where it fits in like in the security space. I don't know if you guys have seen this mind map before. It's kind of like a big mind map of like what's kind of like out there in terms of career paths and like domains within like the realm of security. And as you can see, it's huge. I don't know if you guys can figure out like or pinpoint like where exactly detection engineering is. It's just like on the bottom left corner there, just like right beside like incident response. It's just like one bubble. So it's very important in like the cybersecurity like space, but it's just like one facet of it, right? So it's pretty. There's a lot out there to learn. Okay, and with regards to kind of like detection engineering, it's not like a siloed kind of like function. It interacts and also like integrates like with a lot of other functions that like an organization might have. So like you might interact with like the research folks. So like me and Tass, we have like, it sounds silly to say, but we have like a background in threat hunting. Like that's like our first role outside of Sheridan, and that kind of like led us to like transition into like more focused detection engineering work. But yeah, there's like all these research roles like threat intel, like any red teaming, and like vulnerability management roles. There's also like the engineering aspect of it, which is like you need to maintain like a platform, a pipeline that all like these rules like run on. And you're feeding a SOC or like an operations team, right? Like you're not going to manage or handle all those tickets that or alerts that you're generating. You need a team dedicated to monitor those. So there's going to be a lot of interactions with them. And you also need to work with like logging or like these like sysadmin teams to kind of like make sure that like you're getting the logs and the data that is required for like your data for your detections to work. So a lot of pieces that need to interact together. So it's not like a siloed thing. Yeah, so this is more for kind of like an organization, but it's like to have a successful kind of like detection engineering program, you need a couple of things. Like one, you need people, right, to actually like maintain and build out like your detection use cases. You need logs, right, like and telemetry to alert on. You need a platform, so like you can't just work off of like a CSV, right? And you also need kind of like the organization maturity, so like proper processes, infrastructure to kind of like support this this program. Yeah. So.
Yeah. So yeah, I think the main topic tonight will be like how can we become a detection engineer and what's the everyday looks like for them, for us, I guess. Yeah. So there are three main things that we do as a detection engineer. So first thing first, threat detection. It's pretty straightforward, right? And then you need to ensure that the detection itself is alive. So you have to maintain them, you have to manage, you have to improve, you have to remove them when needed. And then while doing that, you're building also a relationship with all the stakeholders, all those smaller circles outside of the black circle. So you have to keep that alive because it's just like a normal relationship. You give, you take some. So that's kind of the idea. And there's also a lot of things that intersect with the other, like a body in the security organizations, but this is the main things. These days, there are companies that has dedicated detection engineering, so the title is actually detection engineers. But it can be part of a combined role such as threat hunting. Sometimes they call it like just like security engineering, SIEM engineering. So yeah, there's different titles for this role. So if you see like what is a modern threat analyst, so it is no longer just a SOC analyst. So SOC analysts do back then, you look into alert, something fired, yes or no, that's it. But now this day, if you want to be different, if you want to be stands out from the crowd, you have to know a little bit of things from different roles. Incident responder, like how do you, like do some forensics stuff. Threat intelligence, how do you track threat actor? How do you group them together? Threat hunter, like how do you trace the attack from A to Z to the end? And then lastly, how do you build detection for it? So if you know all these things, even as a security analyst, it's fairly easy to you to get out from the boring 24/7 role. And then there's a code that I made. It's a master 1 or 2. You understand some stuff, and then you know the rest. So for me, I'm doing cloud these days, but I use work endpoint. For Sylvain, it's probably endpoint and detection like Sigma and stuff. We understand a lot of other concepts. Incident response, we've done it. I've been incident commander several times. It's not my role, but I've been there. Just like he also do like a lot of programming on the sides, like Python coding and stuff. And we know the rest. We know what happened with the MGM in the previous week. We know what happened in the different companies, and we get connection here and there. So that's kind of like the idea of this course. Okay, so maybe just a real quick activity. So this is Uber, a job posting. 1 week after they get breached, I think like a few months ago or something like that. So this is a good job post for the role, but they're a bit late, but that's fine, I guess. Can some of you try to identify like there's like some basic qualification, preferred qualification, like what are maybe some of the important skills do you think for the role? Anyone? I think it's a big.
Sure.
It would be the programming languages. You'll be doing scripting. Also, I guess, knowledge of security logs, like Linux, Mac.
Okay.
Windows.
Yeah, that's pretty good. Anyone else? Maybe giving a shot? Okay.
It's okay.
It's okay.
Friday night, we know.
It's been a long week. Programming is good, but the way we say it, there are three important components here. So first thing is the data. You have to understand what data do you have. So you get this data from all the folks from applications, server loggings, sysadmin, network admins, and you have to be able to identify the threat. So like what threat actor targeting yours, what phishing email coming to your inbox, etc. And lastly, like how to build detection on top of it. Like how can I use certain data to detect the attack?
Yeah. Just before you move on, task I don't want to neglect it's like you don't need programming.
We know programming.
We do. It's like an asset, but it's it's actually very interesting. Like there's a lot of people on my team. They do not have a strong programming background, and they excel very very well at the job. And you'll see why later, because some of the rules they don't require Python knowledge or anything like that. Of course, it's always an asset, but it's not mandatory.
There are pretty popular terms like low code, no code detection these days, but if you know programming, you can make the low code, no code platform.
Exactly.
So you can sell it. So that's kind of the idea too. So we get these three little things. Still me? Yeah, still me. So the first one is threat. Just fairly simple thing. Threat is something that you don't want happen to your company. That's just simple. So how do you learn about threat? So you learn from incidents, from breaches. Ideally, not from yours, but from someone else. Let's say MGM, Uber, or whatever. But if you had one, probably better to use that too, right? Because it tends to reply itself. So there's incident response, the threat intelligence blocks, Mandy and CrowdStrike, Microsoft threat intelligence, you name it, everything. Meetups presentations, you go around Toronto, you go to conference, they will tell all the crazy stuff they've seen. And there's also a framework of known TTPs and risks, etc. So we'll talk about it more later. So understanding the threats is pretty much knowing what to detect. Just a simple example. So you probably you don't know what's going on in here. There's all out there stuff. This is not your normal thing, but the way it's just Microsoft's in a campaign, and these are 1, 2, 3, 4, 5, seven steps of the attacker that they saw inside, that they do in every single tenant that is compromised. So they see these threat actors doing these 7 things every single time, and we're just gonna combine them together, and we call it like, I don't know, like Storm, whatever. So yeah, so the idea is they logged in, they access the target, they just logged in, they buy the credentials somewhere, they don't do like fancy hacking, CVEs, no, they don't, they just logged in, simple as that. So they create an application in the cloud, and then they, for whatever reason, they can give global admin permission or exchange admin permission, and then they started creating like automated spamming using the inbound connector. So it's pretty much, it's no longer your server because it's sending spam email. They get control of it. So that's really fascinating. And then it will send spam probably to your mailbox too. So sorry about it, but yeah. So that's about data. Like, okay, where can we detect those attacks? Where can we detect the suspicious login? Where can we detect the email being sent, the email being spread out? So that's kind of the idea. So we combine it to 3 things: network, endpoint, and cloud. So it's just, by knowing this, you can know like the baseline of your environment. Okay, I will have this many FTP. No, you shouldn't be having FTP connections first of all. But like, okay, SSH mostly from Canada. We see some from Europe because we get some people in Europe. But if I see it from somewhere else, it's probably questionable. So that kind of the idea of how you can use the data. And then yeah, this is just like, I'm gonna go through this super quick. The idea is like when you see this, you'll explore it later and see like, ask questions, Google around, check on GitHub. So appliances pretty much like on the network, like, okay, what about firewall, anti-DDoS, load balancers? Okay, what can you see from there? Probably like IP address, different address, like it could be like the computer address, the hardware address, MAC address, yeah, IP address, and then there's like domain, etc. And also there's technology like NIDS. I think if you had the intrusion detection class, you probably use
Snort, right?
Snort. Snort is just like little brother of the browser Zix. It's really similar. Yeah, and then you can see what protocol being used, FTP, SSH, which authentication, and from there you can see like if there's spike, there's like brute force on the authentication, you can see it from there. And then host, simple thing like, not simple thing, but like the basics thing that you have here is Sysma. We'll talk about it more tonight. But there's like OS query for like Linux, Mac OS, and there's like antivirus too, EDR, Defender for Microsoft, CrowdStrike, and all the other tools. So you can see like what's going on with the process, what's going on with the file. So if you run a process in your computer, it will tell you, okay, I don't know, like Steam launched this game, and then it launched some other services. So you can see it from this application. And then you can see like which file being blocked by antivirus, etc. And the host system, the Windows itself, they do logs a lot of stuff. Some of them similar to the previous one, but there are more to it. Also other things, Linux, macOS, even phones. And then server, some other things. I don't think you need to know it now. And then there's cloud. Yeah, like there's authentication permission. It's different when you log in a computer than you log in the cloud. So it's completely separate logs, completely separate data in it. And then there's like completely different security solution up there. There's like Wiz, Turn Micro have some cloud solution, Proofpoint for the emails, and then Microsoft have a whole thing for it. And then there's cloud application, so like emails, so many things like SharePoints, all those stuff generate logs. So
This is not a sales pitch for Microsoft.
it is not, but by Microsoft. So yeah, so if you tell me detection engineering just reading logs, that's pretty much it. So it's always has been. Sorry that I disappoint you, but the money is good. Just telling you that. Detection is just like how you combine everything. So you get all the data you get from the clouds, you get from the network, you get from everywhere, you get data from today, 10 years ago. What can you do with it? So first thing first, you need a place to store it, like SIEM, SOAR, EDR, so all those you can combine. But ideally, you combine it in the SIEM. And what do you call it? There's some new technology like data lakes. But people say like the SIEM just keeps sucking them back in. New technology, whatever, you'll go back to SIEM anyway. So if you master SIEM like Splunk, Elastic, Microsoft Sentinel, and some other stuff. So if you master of that, that's definitely a skill that you want to have for this particular. And then each data is different. There are IOC, there's TTPs, you can correlate them, etc. So just understand how can I use this data to detect the threat. So that's kind of the idea for this. And then yeah, so this is the thing that we saw before about the threats. So for the unusual login in the Azure AD, it records all the logs in it. So you can tell which login are not supposed to be there based on your baseline. Same thing with creation of application, like whenever someone gives privileged permission, whenever someone creating suspicious connector, transport rules, and then you can even all the way go to the email. Okay, this user has been sending too many emails, and so many of them getting blocked. That's suspicious. So that's kind of the idea of like using the detection for it. So the flow, just quick flow, like how we do it every day at work. So we prepare, so we research, we read, we look around for information, we talk to our friends in the threat intel community, and then, okay, we research the threat. So for example, for phishing, we look into the email itself, and then we try to see what can we find from it, and then we research detection. Okay, we got this particular pattern on the file name. So this is about, okay, come meet me, are you single and lonely, things like that. So you can kind of combine it. You can bring your machine learning, large language model, can we just do something about this? And then once that's done, they deploy it, implementation, and then you document it. Okay, whenever you see this alert, please do this, do this, do this, when you go to the customer support page. And then keep it alive. Okay, when customers say, oh, it's not catching everything, can you improve it? And then you will improve it on the step 6, which is continuous improvement, continuous development, CI/CD. Oh, that's me. Okay. Plan for detection engineering career. So how can you join the gang? So this is probably a path. Oh yeah, you forget about the slides. Nice. How can someone go to detection engineering? So this is pretty much what you're supposed to be. So SOC analyst. So we skip it. We start from threat hunting, and then we go around different companies, and then we do detection engineering because of that. But there are a lot of more ways. You can go from the programmer, so you do some engineering work, and then you work in the company that deploying engineering platform for the detection. So that's one path. A lot of these folks are in Microsoft because it's like half researcher, half like engineering people in there. From Red Team, you can do a lot of things. You can do Red Team first, and then you can help with the clients. You do purple teaming, so okay, I'll take a bit of the red, a little bit of the blue, and then you know what? Let's build detection together, and then you become detection engineer. So this is you start with the data engineer, so you know about data more. Okay, I can make this IP address look like different schema, different field name. I'll make it the same. So that's kind of like data engineer. They normalize the data and such. And then suddenly security folks telling you, can you help us with this? And then you learn more about security. You learn more about the threat, and then you ended up using the data, and then you probably do like some machine learning, LLM for detection engineering. Sometimes project manager too, and they just get pulled to do like some detection engineering project, and then they become well versed in the detection engineering. They become a program manager. Yeah, and of course sysadmin, network admin, they know everything that happens in the network, so they have the knowledge of the data. So they just know like, okay, this action from the user is not usual in our network, and we can say this is bad, and they build something on top of it. That's also detection engineering. So you probably have one question about the paths, right? Like, do you know the way? There are a lot of ways, but this is not the way. Just ask like, what certs that I can get for my detection engineering. I mean, like it's okay to get certs, but like there's, yeah, it's not the ultimate way. There's so many ways that we can do it, and we'll talk about it here.
Yeah, so like actually about like the certs thing, like I know a lot of folks like are concerned about that, and we just want to like reemphasize like it's like especially like you guys like at Sheridan who are in school, like you don't need to worry about certs at all. But even if you aren't a student, it's like there's so many other ways to building up like call it like career capital or like any of like those 3 skills that we mentioned to go on the path of detection engineering. So this whole section here is like we're stealing from like this very popular concept called the pyramid of pain. We'll go over that a little bit later, but this is like our pyramid of pain, but for you guys to, you know, kind of like figure out like where should you start on just learning and building like that career capital, if you will. And at the base of it, start with school. So yeah, like, you know, you probably heard this all the time. It's like you don't study for the grades. It's really just to build like your solid understanding of like the core concepts, right? Like, you know, you probably learned this like in first year, like the CIA triangle. Like, don't forget that. Like, it's like it's not like at the forefront of your thought, like later down the line. But if you really think about it, like it's everywhere. Yeah, like just make sure you know like you pay attention to all like your major courses and stuff, and you know get the most out of it, right? Yep. So then the next step is, you know, you want to maybe like specialize and understand like the role a little bit more, right? Understand like the soft skills and the technical skills. A little bit on that, like when I do a lot of like the interviewing for like our co-ops, and like I always ask like this. Maybe I shouldn't reveal like my secrets on my interviewing stuff, but I always ask like, you know, what is like the number one aspect or like thing that you're like that if you were like a hiring manager, like what would be like the number one thing that you'd be on the lookout for? And a lot of students, they get trapped on like thinking like, oh, it's like they need to be like technically savvy, or like they really need to have like specific like technical skill. It's not about that. Like the first thing like I look for is like your eagerness to learn, your humility, you know, kind of like what are your aspirations, like, you know, like why are you here, and things like that. So it's a lot of like soft skill stuff. Yeah, so I guess like going back to the slides, like, so you understand like the daily tasks, right? So like you understand like that you need to write some documentation, you understand how to like write the code for like your detections, and again like those 3 kind of like core skills that we talked about before. And just try to build more familiarity with like the challenges and innovations within the field. That's honestly going to give you a huge leg up. If you can talk about like, if you have like a, maybe not like a solid understanding, but like at least like a grasp of like the common problems that like a detection engineer goes through. And if you can't figure that out, well, I have the next slide to show you. And also like, you know, you can get this experience like not like on your own, like you don't have to like struggle through that on your own. You can do it through like networking, like at these types of events. So yeah, maybe you need this slide.
Yeah, so yeah, networking with the right people, as Sylvain mentioned, it's not complicated. We get the medium to do it here in Toronto specifically. You start small. If you're coming to this meetup once every 2 weeks, that's already a good start. You'll meet different people from industry presenting, such as us, and then you can go to the more, you know, like bigger communities. So not only for like school folks. There's DEFCON 416 Toronto. We'll be there. We'll be presenting almost similar topic to this, but like more advanced in November. So if you'll be interested, we'll see you there. There are also TAS, Toronto's Area Security Clutch. Similar to DEFCON, it's just like people presenting their topics there. And then of course there's also OAS for if you're interested in application security. And then yeah, if you've done that, you can go regionally. You can see some conferences out there. So the neat thing is they need volunteers, and when you volunteer, you get free ticket. So that's kind of the idea, being a volunteer. So yeah, like besides Toronto, it's coming in October.
I think so,
Yeah, I think it's October. Besides Montreal, happened already like a few weeks ago. Sector, somebody had discussion like, should I go for the thing on the Discord? But yeah, just get the student pass for the floor. Just look around different products, look around, say hi to different people. So yeah, the thing is that we wanna emphasize here. So networking is not just adding people on LinkedIn or like say hi, just just for the sake of saying hi. But it's more like actively involved in the discussions. You're having discussion, you're having conversation. Some people even ask like, do you want to be my mentor and such? Well, yeah, if they have time, if they are willing, they'll probably say yes. The worst thing they can do is say no, not right now. Maybe they can, you can go to this guy, they will probably help you with that. So that's kind of the idea for that. And to understand the role is different from different companies. So if you're able to know like which company are doing what stuff in the detection engineering field, you can kind of, know more about the role. So for Microsoft, there will be a lot of roles. They put detection engineering under the name security research. So you'll see everything from the red team cloud all the way to, like Android malware in the same title. So, but yeah, just look around for the roles. There's Google Cloud Mandiant folks also. If you're interested in the cloud kind of security research, you can check the folks at WIS, Permiso Security, and also SecureWorks. If you're interested in networking, you're talking about identity, you can check Okta, of course Cisco with all their network appliances, and also Palo Alto. And if you're interested in the email stuff, you can check Proofpoint, you can check their blogs, see what they're seeing every day, and then Endpoint. There's Arctic Wolf, SpectreOps, there's a lot of companies releasing a lot of good research. And this is gonna be fun. So role play or interview, right? These are some questions that I usually ask people I interview if they want to go to detection engineering role or even just like threat hunting in general. To make it fun, a little role play. The interview question. You pick one.
Yeah, sure, man.
I wrote this. I should know.
Okay, I'll simulate a real interview question I have. So maybe
sure.
tell me about your favorite TTP.
My favorite TTPs. So if you don't know what TTPs is, it's from MITRE attacks. So it's like all known common attacks that people have. So my favorite TTPs is probably PowerShell.
PowerShell.
Because it's always been there from the start of time. It's probably in the first or second day when God created the world. God created PowerShell. No, I'm joking. So it's there, and it's always been a problem all the way up every day. And I actually did a whole presentation on PowerShell attacks, so that's why I love it.
So maybe first talk about what are some common threats around PowerShell? Because I know normally that would have been the answer.
So PowerShell, it's literally built up in every single Microsoft stuff.
Okay.
On your laptop, on your computer, on the cloud also, they get Azure PowerShell. So it's really easy to use it. There are some functions like IEX to download file, execution, like hiding stuff, etc. So you can use all of them together. So that's why it's really easy to use for the attacker.
Okay, so in your experience, how would you go about detecting it?
So I will be using the first main data source I will be using is with PowerShell logs that I have, that you have, I hope your company have in the Windows system. But we can also use execution of from sys1if191, which is record all the execution of PowerShell, and you can see like which child process, etc. going on in there, and all of other things too, right? If they're doing network, you can go to the network devices and such. So yeah, that's pretty much it.
Yeah, no, straightforward.
Okay, did I get the job? No, but like that's kind of the idea.
Yeah. So the takeaway there is you typically ask for a attack or something that you're familiar with, right? And we're just trying to gauge what is your understanding of the attack, what are they trying to gain from it, and then because this is a detection engineering role that you're applying for, it's like, okay, well, great, how would you detect it? So
yeah, so it's pretty much the three things: threat, data, and then detection. Like what are the threats around PowerShell? Like what data do you need, and how can you use the data to detect it?
Yeah, absolutely. Okay, so I kind of jammed this slide in because I really wanted to talk about it, but we don't have, this is not the right venue for it, but I want you guys to think about these problems, maybe its potential capstone project ideas to think about. So these are problems that, like, as a detection engineer, we encounter like every single day. And it's some of these, like, they sound like really basic, but you'd be surprised like on how much pain some of these challenges pose for us. So one of them is about testing in QA. So it's like, how do you verify like your code is working as intended? How do you verify that, like, you know, it's actually going to detect like the bad guys when it happens, right? Data schema. It sounds very basic, but it's like, can we use the same fields and logs? Like, can we like have like one common field for just like client IP? Like, it sounds very basic again, but trust me, it's a big problem. Another one is like enrichment. Like, okay, great, you have an IP that comes in. Can you tell us more about it? Is this like is it from like this country? Is it like external, internal? Things like that. Costs, we're always trying to reduce. This is a business. We need to make money. We need to not lose money. So think about like how to build detections, how to like have a platform that is cost effective. And this is the most common one. False positive, true positive ratio. So you build a detection, your analysts complain like, this is way too noisy, but like you need to somehow justify like, you know, the false positives, like they're worth it because when we do catch something, like it's gonna be big, right? So you need to kind of like build like that, I guess like the metrics around that to justifying your use cases. Or maybe it's, you know, justification to cut it off, right? So stateful rules, correlation, also like, again, yeah, just like how do we gather metrics to present to the leadership, and things like just documentation. Like no one likes writing documentation, but it's very crucial for analysts and for, you know, your stakeholders. So these are always like very common recurring problems that like every detection engineer like faces, right? So okay, so moving up the pyramid. So we're gonna explore some interesting niche resources. I wouldn't call them niche actually, but first is like we'll talk about like the when. So we'll introduce the topic of like the cyber kill chain and the new unified kill chain. We'll talk about like the why, like why are we detecting these things. So we're going to talk about like the real pyramid of pain, and just getting an understanding of like the true positive to false positive relationships, and also like the effort that is required to bring out a detection. And then we'll obviously talk about the MITRE ATT&CK framework, because you have to talk about the MITRE ATT&CK framework in a detection engineering talk. So maybe you guys have heard of it, the Lockheed Martin cyber kill chain. If you haven't, it's kind of like this model that the military has like created to kind of like highlight these high-level objectives or steps that an attacker usually takes. It's kind of outdated. There's a lot of criticism against it, like being like it's too fixed and it doesn't really follow like real-world activities. So they made a new one called the Unified Kill Chain, and Paul Poyos, sorry if I butchered his name, and like a university, like they developed something called the Unified Kill Chain that integrates more of the MITRE ATT&CK framework. And you kind of like see that there's like three major kind of like areas or cycles. That's kind of like the major takeaway that you want to get from this is you have like these initial, so you have like your initial foothold where you have like a bunch of techniques or strategies to getting your foot in the door and like breaching like your target. And then you want to either like establish like some persistence or propagate further. So that's like the middle one. And then you want to like achieve like what you came here to do, right? Which is like either like, you know, disrupt the infrastructure or like set up your ransomware, or you want to exfiltrate data, like whatever it is. But yeah, that's like the main takeaway. Like you just need to understand like those key kind of like steps, and then you essentially map tactics towards it. Okay, onto the pyramid of pain. So this is developed by David Bianco. Like he's like my role model in like the detection engineering role, or more threat hunting. But anyways, we'll talk about like who you should follow like after. But anyways, so what this pyramid is supposed to highlight is kind of like the effort to pain ratio for an attacker, like if they were to be like stopped at that level. So if you build a detection for hashes, it's very trivial for an attacker to modify their
What
file.
is hash?
Right, so maybe anyone want to answer that? What's a hash?
It's not from Tim Hortons. Hash browns.
Hash mask, yes. It's a fingerprint, right? It's a digital fingerprint for a file. So those get easily modified by just changing one bit, right? It completely changes like their fingerprint. So very easy for an attacker to change. IP addresses are very easy to spoof and to change. So as you get further up this pyramid, it's a little bit more difficult for the attacker to modify or to change, but the difficulty for us increases. So it's a little bit more difficult for us to detect on like specific behaviors or like their tools. But if we succeed on cutting off like access to like a very common tool like Metasploit, for example, then it's very difficult for these attackers to change like their ways, right? So at the very peak of it is TTPs. You can think of it as just behaviors, but it's an acronym for tactics, techniques, and procedures. And we'll talk about that when we address the MITRE ATT&CK framework, which is now. So there are 14 tactics, right? So the tactics are the columns, and they're kind of like laid out in like chronological order of kind of like the kill chain. You just need to understand that like these are like very high level objectives that an attacker wants to achieve. So maybe like if they want to do some defense evasion, there's a list of known techniques that are out there that are actively exploited to achieve this this objective of like like defense evasion or credential access or whatever. So for every technique, so the technique is kind of like the idea of the attack, and then there are procedures. The procedures is like the actual implementation of the attack. But when we talk about that, we typically just refer to it as TTPs. So feel free to browse this like on your free time. It's a lot of stuff. Like there's no expectation for anyone to know like every single one, but at least like the high level tactics, it's pretty good to know. Oh yeah, this meme. So it's like, you know, you see a job posting and they expect you to have like 10 years of experience, even though like, you know, the field's only been like here for like 5 or something like that, right? Like how do you get ahead of the curve, right? You guys are students. It's like, how do you get the experience that employers are looking for right out of school? Well, this is how. You work with a home lab. So all of the tools that I work with right now, or maybe not all, but most of them are open source. So I'm not going to name which ones, but for example, one of them that's very popular is the Elk Stack, and another one is Sigma rules. So these you can use and just play around with on your own and build the experience on your own. So there are home labs and there are like online labs, things like Boss of the Sock, or where they give you like a sim to play with. Those kind of like help, but it's really helpful for you to like learn how to set up like your own platform or your own stack, so that way you get like hands-on experience on kind of like the platform that you're working with and understanding like those limitations. And there are like vendor sims. But the key thing that you really want to have like experience on in detection engineering is of course like the detections. And honestly, like the best one or the best repo for this is kind of like the Sigma rules. And we'll talk about what those are in a sec, but there are also like Yara rules for like files and like for malware, Snort for like network stuff. And you know, if you want to be creative and really work your programming skills, you can make your own stuff. So. Okay, so first we'll talk about Sigma, what it is. So it's a generic signature format for SIM systems. So these are rule formats for rules. So instead of like writing the same rule like different ways for every single platform that you have, you can use like a Sigma rule, which is a common like format, and there are converters to convert it into like your specified like platform. Yeah, it's attack surface agnostic, so I don't know if it shows up well, but there's like Sigma rules for like Linux, for network, cloud, and of course like for endpoint, or like Windows. So yeah, it's a really great repo to get your like your feet wet and just start playing with like these detections.
I just want to add something here. Maybe one thing why we put it here, because it's open source and you can actually contribute to the repo itself. So if you find something interesting, you run it on your lab, and you generate the Sigma rule, it detects the malware or whatever, you can open a PR on the GitHub page there, and yeah, that's all. When you go to the interview, like, and they hear like, oh, I submit a PR to Sigma, they're like, oh, okay, well done. They probably get a job pretty soon. Yeah, so that's kind of the idea. But also, this is like the kind of like the general one that is out there. It's been out there. But if you are interested, for example, working for Microsoft, so you're probably going to be looking into different languages. But it's kind of the idea of like knowing what languages or like what rules that they're using. So Elastic with the AQL, Microsoft with KQL, Splunk with the SPL. So knowing those stuff, it's good to know. Yeah, kind of.
Yeah. So yeah, just I think the slide or the image on the right here. I don't know if we have time. No, let's just go. Okay. All right. So yeah, very quickly. So just the things in blue is just like the meta information. You need to know like who wrote it, like the references for it. You want to also tag it with like the MITRE information, so that way like this is like to populate like your coverage. So if you want to know like there's a cool tool for MITRE that shows you like just essentially like how much you're covering like this technique or like this tactic. Anyways, the meat of this the Sigma rule is what's in red, which is like the detections area, and just like it's pretty easy to read, right? It's just like, okay, so we're looking for something called selection, and the selection is looking for an image. So image is like their word for, or their name for like application or executable. Thank you. I was about to say image again. So we're looking for an executable, right, that ends with tor.exe or Tor browser, like this directory, firefox.exe. So this is a detection that Sigma HQ has for detecting the use of the Tor browser, right? Very straightforward. And you can get very creative and really crazy with like the logic in the condition area. So yeah, but this is like a pretty good example to start off. Okay, so the pipeline. So just giving you guys ideas here. You want to have a, like as a detection engineer, you don't need to like directly implement or support like the platform, but it's very good to know like all of the pieces that you need to work with for your detections to work, right?
You're probably gonna get fired last. So if you know all this stuff, so all the researcher will get fired first, and then you.
Yeah.
So your job will be safe, pretty much.
So first, you want to understand where your logs are coming from. So the log generators. So for endpoint, for example, we'll have like maybe like sysmon logs or like Windows logs. You need some type of tool or like a forwarder or a collector. So like Logstash in the Elk stack fulfills this role. There's also like Wazoo, which is like also open source, or you can use like WinLogBeat for like yeah. Anyways, it's all part of like the Elk stack. Then you need to store that data somewhere. You can use Elastic database. There's also like OpenSearch, and you're going to need a way to interface with this data. Okay, great. It's stored. It's like nicely indexed. You need a way to interact with it. So that's where Kibana comes in. Kibana is just like a front end to dig through the data. You also want to have like I guess like an alerting component to it. So maybe you don't want to like constantly stare at like your visuals or like the diagrams that you make. So you use like a last alert. Or you can spin up like your own framework, or there's like some open source frameworks out there that we'll talk about. But you can also use like maybe like a Jupyter notebooks, and create like your own hybrid of alerting slash like detections on top of that. So
Yeah, so I think the beauty of this is like, it's up to you, like how far you want to push learning. I want to do machine learning, you're probably going to do it in the Jupyter notebooks because that's what machine learning engineer does in Microsoft. So they just use Jupyter notebooks everywhere. So it's going to be the same thing, but like, yeah, it's out there, it's free. It's up to you where you're going to go.
okay, all right, yeah. So this is there's a lot of stuff. There's a lot of stacks. I found like this cool repo from ResWeb 10. You can probably check that one out, and he has like a bunch of other reference resources on how to build your own stack for like a home lab. The very top one, this is like your common elk stack. So this is like the one that most people are familiar with because it's free and open source. One of the blogs, which one was it? I think it was the Sock Fortress Medium blog. That's referring to the second diagram here. So he has a very interesting take on building his own home lab. He's using, what is that tool called again? It's like Hive or something like that. It's case management. It's more like for forensics. You can tell this person has more like a forensics background, but I think it's pretty interesting still, the tech stack that you can use. The bottom image is the Helk stack. It's pretty outdated, but it's from Roberto Rodriguez, another idol of mine. He has a lot of great research, which we'll share later. But the Helk stack is kind of like his elk stack that's used for threat hunting and a little bit of machine learning stuff. But you can take away the machine learning stuff and just work with Logstash, Elastic, Kibana, and Elastalert, and boom, you have a nice stack to work with. So yeah, resources for you guys to check out after. Okay, so we've been mentioning Sysmon a lot. I just as an endpoint specialist, if you will, I feel it'd be a disservice to you to not talk about Sysmon. It's a Windows endpoint log. It's just a software by sysinternals. Honestly, it's just one guy at Microsoft that's working on this. Actually, just one guy. And it's a service that you run on your Windows machines that generates these Sysmon logs, and these Sysmon logs track various behaviors. There's I think up to date now 26 or something like that. But to start off, you might want to edit the configuration and just start off with these three logs. One is event ID 1, which is process creation log. On the right there, I don't know if it comes off well, but this is an example of a log. It tells you which image or which process was instantiated, and then what is the parent process. It also has a hash and a bunch of other stuff. But honestly, it's the parent and child kind of relationship that's really interesting. And you can see the command line for it too. So what were the parameters that were fed to this process. On the bottom left there, I have a diagram from the Threat Hunter playbook. This is Roberto Rodriguez's blog / research website. He posted this, and it's a really cool way to visualize the relationship between all of the Sysmon logs. And honestly, it's a very good exercise for organizations to do to get a better understanding of their data. But anyways, that's pretty advanced. Okay, yeah. So the last one.
Yeah. So another thing that you can do, and I think after doing all of that, heavy stuff, home lab and stuff, it might be nice to brag a bit, to share with people what you have achieved. Yeah, it's really easy to create a blog post this day. You can just use GitHub page, Medium, LinkedIn also have some functionality for it. You can start a YouTube channel if you want. A lot of people are doing it these days. And you can just submit presentation to here, to B-sides, to different conferences if you're feeling good about your content. To understand or to know what is a good blog, you can follow these 3 links that we have here. DFI report, it's a shameless plug. I'm one of the contributor in there. And we do have standards, so we do have things that we put in there. And if you create something like that, sure, people will call you like, oh, you follow this? Yeah, I follow this because it's good. Like, why wouldn't I, right? And yeah, there's different things like the initial access, what they do, what they are doing inside execution, etc. There's some intro, there's some TTP sections. So those are good things to follow if you want to do some kind of malware analysis on your own. SpectreOps is really good, just like in the high level, like thought processing. Yeah, it's just really interesting. And Splunk, it's kind of similar to the FI report, but they have really good content in there, so you can use it as a for your mind map. Okay, this is what I'm gonna do for my blog, etc. If you want to know what to research, you can go to Twitter or LinkedIn to see like what's going on. And then that's pretty much the start of the share. So this is just some inspiration, right? So you go back from this place to that, and you start spinning up your system, and you're like, okay, this is complicated. I'll create something, some blogs about it. And let's do System 101 with me. You release like 7 series, how to install it, how to collect the data, how to play with it, how to create detection, and then maybe you have subscription to Hack the Box or Try Hack Me. Okay, how do I complete this hacking challenge? And then you put it on your blog. And then like Splunk, you can deploy your own AD environment at home. Maybe you have the lab, and then you just want to see, well, okay, I want to try to detect, maybe not MGM because it's mainly from phishing, right? Maybe some other company that getting breached, and you get the malware sample. You know what? I'm gonna reverse engineer it, and I'll see like what's in it. In the secure and network certificated home lab, and then you just write a blog about it. Okay, how do I investigate it? Just some personal story. Two days ago, I got phishing email on the booking.com, like booking, travel booking. So the hotel itself, the hotel themselves, they send me a link to confirm my credit card information. Now that sounds suspicious, and then of course there's typo and everything. Okay, this is not good. And then the next day, another hotel that I booked sending the same thing, so we know this website is compromised. So I'm right now building a blog on that. I pivot on some online tools, and I find it's related to like some campaign in New Zealand Post and some other things to kind of bring it together. So that's kind of the idea. Okay, you see, okay, I receive, you probably receive it in your phone, like return from Canada, tax, blah, blah, blah. Go to this website to get it. Maybe follow along that. You see like, okay, which IP address, which infrastructure do they have, what other type of phishing that they do. So there's a lot of inspiration out there. You just go around, see like what people do. You probably get inspired really quickly. And I think we're pretty much almost done.
I'm not sure if the takeaway from that was to do kind of like research, or that you have 2 hotels booked and you have a nice vacation planned.
Yes. but if you want to explore, we mentioned that Sigma is great, but if you're thinking about, okay, well, I want to work for a company that uses Elastic, you can check their detection rules here. Splunk, other companies, even Google Chronicle. Google have their own SIEM, and it's Chronicle. And then Control Compass is really interesting because they collect everything. So pretty much all of these are in there. So if you click the TTPs, maybe PowerShell, and then they'll show you, okay, Elastic has this, Splunk has this, Microsoft has this, etc. I don't know if it's still maintained, but it was good. Well, it was. And then there's some open source detection engineering collaboration. YCD. Yeah. So they do like a sprint of like collaboration to build detection. So they have the material, they have the research ready, and they just need people to turn it to detection. I think mainly Sigma, and there's also some other stuff. So if you check the link, I don't know if they are doing it anything soon, but it's just a nice place for you to gain experience, to play with the detection. And then OTR, OTRF, it's just a community solely for the threat research. Organization you want to check, fairly simple. If you like to know about data more, you can check the Awesome project. This is also by Roberto Rodriguez. So this is all just like data dictionary. So Sysmon, they get everything in there. They get everything from Microsoft. They get everything from Amazon, Linux, etc. so you can understand the data better. Yeah, this is just a lot of ratings. If you ask like, where do you cut the line between detection engineering and threat hunting, you can check it with the block, the first block. Like how do you prioritize building detection, etc., funnel fidelity. Yeah. And then these are people that we would like to suggest to follow on Twitter or X. I know it's like that platform, but it still works pretty well. Yeah, just follow them on Twitter, see like what they're tweeting. If you see they retweet something nice, you can just follow the other folks too. I think that's mainly it. So yeah, thank you so much for the time. And if we have any question, we are available for question. I think time is good too, right?
Yeah,
Okay.
let's check this.
No questions?
So, I don't know if you guys saw, TCM Security came out with detection engineering course. Have you guys, I guess, like, looked at it and then, like, based on your experience, like,
Oh.
what would you think of it?
I haven't personally.
Which platform?
TCM.
TCM?
No.
Yeah.
Yeah, because it's dealing with, like, ELK, and then you're pushing rules to, like, GitHub and stuff like that.
It's probably really similar to. I think I looked into some of the TCM courses.
Yeah.
I think it's fairly, for the price that they offer, I think it's pretty good options if you want to look into it in more like structurized way. But yeah, I think you can start with that. You can kind of explore around. I think it should be good.
I'm kind of curious, like on a beginning level, like how do you actually decide like what to even start writing detections for, right? Like from like the research phase, like is that something that you guys deal with, or is that like research comes in from other teams? Or
No, absolutely. No, so this is an excellent question. So maybe for the mic, the question was, how do we prioritize like our detections, right? Like there are so many bad things that are happening out there. How do you know like what is the thing that you need to focus on? And honestly, this is like a whole talk in itself.
Yeah.
But to give you like a very short answer, it's there are multiple factors that you want to consider. One, are those threats even relevant to you, right? Like, do you have the logs for them? Is like a very big question. Secondly, what is the impact, right? So for like vulnerabilities, you have like the CVSS scores, right? For threats, it's more like we don't really use that. It's more like based on like threat analysts kind of like assessment. So it's like critical, medium, like high, medium, like that kind of severity. But we typically rely on our great threat intel team to give us like a heads up on that. So that's one way. And then the other one is like kind of like how difficult is it to really like detect it, right? Like, are you gonna need like machine learning? Are you gonna need like a huge data lake to collect all these logs to figure it out, right? So if you have like these kind of like, we'll start with like those three factors, right? You can kind of like derive like a score or like a parameter on like, okay, this should be like what's priority, right? So that's kind of like how you want to think about it, like a way to think about it, I should say. So
yeah, that makes a lot of sense. Thank you.
yeah, no worries. Great question.
Yeah, I think maybe even like if you got breach or something,
Yeah.
everything shift. Like, okay, we gotta cover this, we missed this. And yeah, they will spend money on your capability to detect that particular breach. So it's always, it's a challenge that we face every day. For like big companies, they even have like program managers, project managers just managing the loadout. So the researcher can focus on their own. But it's probably like 5%, 1% of companies doing that. But most of the time it's gonna be the researcher that is doing that because they know really what to expect, right?
So you had a question?
Yeah, you guys mentioned using LLMs for some detection engineering. Are you using like open source models, or do you guys have like a model you're working on in-house?
Oh, we do have.
Well, I mean, he's Microsoft, right? Like,
The open source is our own. No, but we do have like a lot of like in-house data engineers, machine learning folks, and yeah, we don't really talk much about it. Yeah, but like it's the open source is it's would say it's pretty good, right? Like all you need is data sets to train them on top of it. So I think probably the first challenge, if you want to do some project in school, maybe you can start gathering like available, like data sets, and then you kind of collect it, and then you start training the model on top of it. One of my coworkers just published a machine learning model. I think it's based on ChatGPT 3.5 or I think 3.5. So the model it's able to tell. So you pass them an article about cybersecurity breach or incident, and then it will tell you which TTPs are in there. So it's pretty much the idea of just like gathering different research from different companies and just putting it together. So it's doable. I think I asked like how much does it cost to train them? It's like $200. That's it. Small one.
So like, what's your how good is it? Would you say? How much does it help you with the new detection engines? Like, is that at the high like false lens at the moment, or?
No, I think we do have some great. It's good. I would say it's good. It's
He's
good.
legally liable to say that his product is great,
it's good.
right?
There's no way I'm saying it's bad. No, but like seeing some other folks also doing that, it's fairly good. Of course, there's gonna be false positive. Right? It's not a complete 100%. But yeah, it depends on your data. But most of the time, it's really good.
Yeah, and I want to kind of expand on that because like, you're talking about like language models, but there are machine learning algorithms that are like way simpler and that are like just as I would say even more effective. I forget the one. David Bianco has like a really great talk on this, and maybe like that's like an Easter egg hunt for you to like find out. But it's like there's very simple algorithms that can get your foot in the door of like this is how I start working with like large data sets and like training a model. So, yeah. Any other questions? Yeah.
You mentioned to learn more experience and explore the new technologies, we should start looking at a home lab. For me, someone who's still in the second year and learning about new technologies, home lab is something that's still very far.
Yeah.
So I would rather prefer to upload this standardized curriculum. So are there any certifications or domains in security domain which you would suggest can still give you some leverage?
I would push back on those certs, like honestly.
Yeah,
but like with the home lab, like we gave you some resources just now. Like they're like YouTube videos that you can just follow along, and you can like troubleshoot your way through like Stack Overflow it. Like it's just it's part of like that's part of like the experience that you're trying to learn, right, and build. So
Yeah. So I think it's a pyramid of pain, right? So and you see at the bottom it's school, and you're still in your second year. You barely scratch anything about security topics in the school, because I know I've been to the program itself. So yeah, I think you just need to focus on school first, explore like what's in it, because based on the statistic of the program, 50% of people might not be there after third year. So, well, I'm not saying that hopefully you're there, but like it's just focus on the school, try to get more understanding on the non-security topics, networking, database, etc. Because networking peoples, when they know their stuff, they know the data, and then from there it's easy to connect it to different things, threat detection, etc. If you want to do machine learning on the from the data itself, it's easy because you understand it. So I think it's a pyramid. So you have to kind of go through each one of the steps, and I think it's on the second from the top, right? The home labs, yeah.
yeah.
So it's still a long way. You still have 1 year, a few years. Everything changed, like the technology changed. So yeah, just take your time. Start with school, focusing on that, and then try to get some interest on certain topics. Maybe start looking around on the different steps in the thing. Yeah. So that's mainly the idea.
Do you guys have any nice or free alternatives to Splunk? Because Splunk is paid software. Do you guys have any?
We said it many times, man. The elk stack. It's tried and true. Like, there's a reason why like a lot of people use it. Like, the ELK stack.
Elastic.
Elastic.
Elastic stack.
Yes. Yeah, so it's one of the stacks that's like one of the labs that's or home labs that you can set up in the presentation. So I don't know, maybe you can just.
I think I think Splunk it's also,
There should be a free one, right, for Splunk?
some of them should be available, some of the feature, not the machine learning
Not
and
the whole
everything.
I think it's Splunk Enterprise.
Sorry?
I think like it was Splunk Enterprise, there's like a trial version of it.
Yeah,
Yeah.
so you guys can get like a trial version to get your hands on it. And I think I've interviewed quite a few of you guys, and I'm pretty sure you guys have a class that touches on boss of the SOC. Like it's one of the things that you guys do. So yeah, so maybe if you're not in year 3 just yet, you can get a head start. So.
I'm taking that for a course where you use Splunk, that's all I was asking.
Ah, okay, cool. Okay. By the way, I love that that's a class. We didn't have that like when we were students, so like pretty jealous.
Oh man, I learned by myself.
Yeah.
Well, there's like a lot of things. I think if you go to Microsoft, if you sign up for the, I have to.
It's not a sales pitch,
I
guys.
have to. No, you get like $200 credit on the Azure, so you can spin up whatever you want in there. So that's kind of like playground for you. I don't know if you've seen. Yeah, it might be expensive, like millions. Yeah, but I think you can if you want to learn more about clouds and stuff. And also, yeah, there's like most of the stuff, right? It happens in the period of time in the year. So I think when that happens, you can just kind of join it and play and get more exposure to the Splunk. But the best way to learn it, it's this Splunk, Elastic, because it's completely free. You can spin up whatever you want. There's also the version from Amazon,
OpenSearch.
OpenSearch.
Okay.
It's really similar. Elastic's hates them because they kind of stole the code apparently.
It's a,
But-
what is it called? It's like
Fork.
it's a fork of it. So
Yeah, but like, yeah, I think that's the main one that people use these days.
it's the other reason why I like the ELK stack so much is that it's split into all of those 3 components, so you get a better understanding of like all of the pieces that's kind of like required in like a pipeline. And you can like actually mix and match them. So if you don't like Kibana, you don't like the front end of that, you can switch it out with
Grafana.
Grafana or like Jupyter Notebooks or whatever. You don't like Elasticsearch, you can use OpenSearch or whatever like data like you have like access to. So yeah. So. Any other questions? Yeah, and just thanks again for your interest in detection engineering. I know it's a Friday night, so you guys have other things to do, but you guys are here, so thank you so much.
All right, thank you, Taz and Sylvain, for that presentation. Thank you, everybody, for coming out. We'll be hitting Monahans and ISSessions. We won't be back 2 weeks from now because you guys got midterms. Good luck with that. November 3rd, we'll be back, so mark your calendars. Till then, have a good night, everyone.